Thank you very much for coming to what's the last sort of full dev session of the week. Have you guys all had a good conference? Learned a lot? Excellent. So my name's Ben Robb. I'm a SharePoint MVP. This is my fourth session of the week, so some of you will have seen me before. I'm also CTO of a gold partner called Seascape. And we've been involved in the SharePoint space for 9 years or so, since pretty early versions, and also in the WCM space through MCMS, and before that Encompass Resolution. So a fair amount of history in building websites, public-facing websites in SharePoint. We also built headcandy.com, which was one of the early 2007 releases. So what I'm going to talk about today is what is high when I'm talking about high scale and high availability. Why is it important? How do you test for performance? And what are the factors that are going to really impact on the performance of your site? What should you be looking at? And there I'm going to focus on three main areas. How to reduce the load that your server has to deal with. How to reduce the page payload. So how to reduce the total amount of data that's going down the wire to the browsers, and how to reduce the number of requests that are actually going to hit the web server, and so on. And then I'll talk a bit about high availability. There's sometimes a bit of a trade-off between performance and availability, right? Sometimes some of the things you want to be doing from a performance point of view are going to reduce the availability of your servers, and vice versa. Some of the high availability stuff will have an impact on performance. So I guess what you need to be thinking about is how that trade-off works for you and your solution in your particular scenario that we're talking about. I'm not going to be talking about deploying large SharePoint implementations in detail, right? Apart from anything else, this is a dev session. Steve Smith did a topic on high-scale implementations for the IT pros, I think earlier today. So if you're interested in that kind of side of it, that's the one there. This also isn't a deep dive session, so I'm not going to be doing lots of code examples. I'm going to be talking through some concepts rather than showing code on the whole. I'm also not going to be talking about how you write tests. Different types of tests. I'll talk about the sorts of considerations you need to have for how you should be planning your testing, but I'm not going to be doing detailed test planning. And I don't have any metrics. SharePoint only went RTM last Friday, so, you know, no one's had a chance to actually run real-life testing on the RTM product yet. So, what is high? When you think about high-scale sites in terms of user base, you think about sites like Facebook, sites like Twitter, news.bbc. These are all sites that are really high in scale. But it isn't actually as high as people think. Really, if you're in any kind of situation where you have a public-facing website and it's more than a brochureware site for something that only gets 20 hits a month, you're going to have to be thinking about a lot of the pointers that I'm going to be raising in this session. And really, as a best practice, you should be doing this stuff anyway, because you don't know how many users you're likely to get. You don't know when those users are going to be hitting your site in a public-facing scenario. The other thing to say is, nothing I'm going to say today is specific to SharePoint deployments. You could be talking about a classic ASP.NET website. You could be talking about a Linux website, you know, running Apache. A lot of the concepts that I'm going to talk through are equally relevant in that kind of situation. So just because I'm talking about 2010 doesn't mean that when you're rolling out 2007 implementations in the next month or so, or supporting existing implementations, you shouldn't be putting some thought into this kind of strategy. So why is it important? On public-facing websites, there's been a lot of research over the last 30 or so years. People like Myers and so on have written detailed papers on, academic papers on why it's important that servers respond quickly, that websites are fast. And there's been a lot of research, real-life research, analyzing the impact of performance on tangible things, tangible outcomes that people can see. So, couple of examples. Amazon did some research where they had a widget on a page that was adding 100 milliseconds to the page load time. When they put that widget on their pages, they saw a 1% drop in sales across the board. And for a company like Amazon, which lives on that kind of thing, that's huge. That's millions of pounds, millions of dollars. Similarly, Google, and in fact, there's other stats similar to this that have come out of Live and Bing research as well. It's really important for websites to be quick. There are basically 3 magic numbers around this. In interface design in general, if response to an action like clicking on a link is measured in the sort of 100 milliseconds or thereabouts response, the human brain thinks of that as instantaneous. It can't perceive there to be any delay. Once you get to about a second, people are still engaged, they're still willing to accept that it's a continuous application, it's not asynchronous. But they're more likely to be distracted. By the time you get to 8, 9, 10 seconds, that's it, you've lost them. They're on Twitter or Facebook or something else. They've gone somewhere else to find that data. They don't perceive it as being a continuous thing. And that's fine for a home page, but when you're in a situation where you're going through some kind of transaction process, like a checkout process, that can lead, a slow response time can lead to a dramatic fall off in conversion rates. So it's really important, whether you're selling products online or whether you're just serving information, it's really important that speed is there. And it also should reduce your running costs. If you optimize your system, you'll need fewer servers. You'll therefore need fewer software licenses. You won't need to spend as much on maintenance. You will have higher testing and development time, particularly if you don't do it right first time. If you're having to retrospectively optimize your website, that's hard. Though there are tools out there which I'll show how you can do that. So what sort of tools should be in your arsenal? There's basically 3 types. The first is around browser testing. So you should be using things like Fiddler and YSlow to really gauge what parts of your application, what are the problem areas? How do you ensure that your pages in general are going to be optimal? In the SharePoint space, you've also got the dev dashboard as well, which will help provide detailed information about load times for all your web parts and controls. In terms of load testing and performance testing, there's a number of tools there. TinyGet is what some of the Microsoft product groups use. It doesn't have a nice UI. It doesn't generate you lots of nice reports that you can show to management, but it gets the job done. It's a very lightweight tool for doing that. Visual Studio has testing tools inbuilt, performance testing tools inbuilt, provided you've got the right version. Unfortunately, they're not in Visual Studio Professional. You have to get Premium or Ultimate. Who's going to buy Ultimate? It's like $15,000. But anyway. In addition to that, there are like enterprise class platforms like LoadRunner from HP, which used to be called Mercury for those who've used these tools. The final type of tool is around software as a service load testing, companies like Keynote. And what they do is they test your whole infrastructure, not just from within the firewall that you're, within the system that you're doing your tests from, but worldwide. So they will be able to show you the performance and the response times from Australia if you're hosted in Europe, for example. And they won't just guess those. That will be real data. They've got servers in most countries around the world which can run load tests against your system. If you're in a situation where you can perceive there to be a significant amount of revenue that would be increased by making sure your site's faster, then it's definitely worth doing at least some testing through something like Keynote. They are very, very expensive, but it depends on your scenario. So I've sort of talked about performance testing and load testing in the abstract. There's basically three main types of performance testing. There's load testing, which is about, I've got a bunch of users, my expected number of users is about this many. How does my application perform when I run a pretty standard set of user journeys against my application? How performant is it? The second type is spike testing. And that's basically trying to break the application. How many users do I have to load onto the server? How many requests do I need to push at the server before it falls over? And then endurance testing is also an important thing. Endurance testing will uncover memory leaks. Endurance testing will uncover where you've got problems where over a long period of time problems build up and will affect the performance of your site. So when you're developing how to do performance testing, you've got to think about what the goals are that you're going to have. So you're going to have to think about, well, what is my likely user load? How many people do I want to be able to access my website at any given time? What's my ideal page weight, given every time a request goes from a user to a server and then back again, that's going to take a certain amount of time for that information to travel. Reducing the page weight is important. So the key thing to do is make sure you're developing test plans as you're defining what your product does and defining what the success criteria are for those different user journeys. And then you need to benchmark. Every time you deliver a new drop of the code, right from day one in your dev cycle, you should be doing performance testing. So that will start off with being pretty much out of the box. You might be using the minimal master page. You might be just using the out-of-the-box templates. How fast does that work without any custom code? How fast does that work without anything that we've done as part of our dev cycle? Once you've got that as a benchmark, you can then compare that with two things. You can compare that with your server topology model and say, well, looking at it really early in the cycle, we were wrong. We don't need 2 web front ends, we need 5. The other thing it does is it means that when you're deploying code and your users say, oh, it's a bit slower than it was before, you've got some real numbers to fall back on and say, okay, so we introduced all of this functionality and there was a 10% increase in the page load time. It's important to be able to benchmark that and work out exactly what introduced your delays. So I'll just quickly show you some of the tools. Who here has used performance testing, web testing in Visual Studio? Very few. That's maybe 15, 20% of the room. Okay, so I'll very quickly show you those tools. If I can find my machine, there we go. So Visual Studio has a project type, if you have the right SKU in Visual Studio, called test. And that has a bunch of item types that are able to be used, including unit tests, including tests for Windows applications, WCF applications, and so on. For a web scenario, you're really interested in two key scenarios. The first is the web test type. And what that does is it lists out a user journey. And it can be quite dumb. It can say, just go to these 5 pages. Or it can be more intelligent. It can be, go to these 5 pages and get some data and fill in a form from data that I've stored in a database somewhere. So it can test, working through a particular process that involves lots of forms. It can also do query strings. So if you want to do testing of search, for example, you've got that available to you. So that's like the building block. And I guess every single user journey that you have that you want to test, you should create a web test for, and then run that as you're doing your check-in process or your nightly build or whatever continuous integration process you're doing. Load testing is slightly different. Load testing takes those scenarios and bundles them together and says, at the moment I've only got one test here, but I'm going to have a mix of tests, so I can say, this is someone hitting my home page and then going to the press release page. That's a pretty standard use case. That's going to be maybe 30% of my users. Somebody doing this other thing, which is registering a new account, that's going to be much lower. Someone doing a search, that's going to be a bit higher. So you can create scenarios which are mixtures of different user journeys based on what you expect your load to be. Once you've launched your site, you can also take the real live data from web analytics and use that to gauge this. The next thing you can do is simulate different browsers using this to connect and give different percentages of different things. Again, you can get that from your browser stats. And then network mix, how fast is the network? For an intranet scenario, you might have really accurate data on that. You might say, well, 50% of my users are on a fast, high-speed WAN locally in this country. 20% of my users are in Singapore, and there's a slow connection between the two. So you can simulate that. And then you can also add machines to the load test. And what that gives you is the ability to run those tests on multiple machines, so you can scale up the load, so that the machine that's running all your tests doesn't have a bottleneck where, for example, the network adapter on that machine. When it's actually running, what it's doing is it's getting counters from the performance counters on the machines. So things like how much memory is being consumed, how much physical disk. And that you'd want on all of the servers in your farm, including the SQL servers. So you'd want to make sure that you're measuring disk performance and I/O and so on, and memory usage on your SQL servers and your web front ends and any other servers in your mix. So the combination of all of that, when you run it, will give you some real numbers and some pretty graphs around what's actually going on your servers when you run that. So that's the first of the tools. Now, if you haven't got Visual Studio Test Premium or Ultimate editions, there are alternatives. So there's a tool called Whatin, which is I'm pretty sure it's freeware, which which does a similar sort of thing. It doesn't have the reports, but you can write web tests with them. Basically, you get what you pay for in this kind of space. The second tool is Fiddler. And this is useful generally from a web development point of view. It lets you know what's going on, particularly if you're doing any kind of Ajax or sort of Silverlight type work. How many people are using Fiddler as part of their day job? Excellent. That's a number I would have thought. So I'm not going to really explain too much what it is. It basically lists all the requests that are coming in. I've got a demo of that later. Good. So those are the tools. So, what impacts on performance? 3 things. How busy are the servers when a request comes into the IIS pipeline? And how much work do they have to do to actually service that request? How big is the chunk of data that's going to be sent down? And how many requests are going to go to the server to actually deliver an entire web page? So there's a number of different ways you can attack these problems. To reduce the workload, you've got some server topology stuff, you've got some guidance on how to do custom code, you've got deployment techniques and some of the pitfalls around different methods of performance. Obviously, you've got caching, so that's a big thing, and you really want to be offloading the SSL. So I'll go into those in a bit more detail. So there's a lot of guidance out there. This is more of an IT thing, IT pro thing, for scaling out SharePoint farms. I'm not going to really cover that here. The key thing to note, though, is even on your dev environments, you should be switching off or ideally not enabling any service app that you're not going to use. So, for example, you're probably not going to be using the Visio graphics service on a public-facing website. Switch it off. It's consuming resources. It's going to affect the scalability of your farm. If possible, separate your authoring farm from your production farm. And that's really important. One of the great things you can do in 2010 is mark databases as being read-only and then use log shipping or SQL mirroring to move data between the two. That will give you a significant performance increase on your public-facing website. Because if you think about what happens when a content database is not read-only, what's happening is every time a request comes in, it has to say, is my cache dirty because something's changed? Because it might well have changed because you've got authoring going on that tier. If you mark it as read-only, all of that logic doesn't happen. It says, it's a read-only database. I don't need to worry about this. So you do get a significant increase in performance on that. You also get, there are other reasons for doing that, right? You get separation of concerns, you get better security model, isolation, and so on. So in terms of the taxonomy of your site, the structure of your site, how you're structuring the data within your site, try not to mix secure and insecure content. So if you've got a members-only area on your website or something you need to log into to access, try and put that, if possible, in a separate site collection. And if you can't do that for whatever reason, at least put it in a separate place in your structure. If you've got secure and insecure content in a single list, that's going to impact on performance. It's also more difficult to manage going forward. So in terms of custom code, which is what all of you will be doing, standard .NET best practice applies here. Make sure you're using defensive coding. Every time an exception gets thrown, you're going to get a performance hit because it has to deal with that exception. Even if you're catching that exception in a catch block, it's going to reduce the efficiency of your code. So defensively code. Make sure that you're checking for null objects before you're trying to access methods and properties on them. And really understand how .NET manages objects. So think about garbage collecting. Think about what's actually going on under the hood when you're calling a particular object. And a specific example of that is things that appear quite innocuous, like an splist.items.count. That's going to go to the list and hydrate every object into memory. That's going to be really inefficient on large lists. So, that's something. Having a clear understanding of what's going on within the out-of-the-box object model is really important. Obviously, the need for SP dispose check hasn't gone away. You still need to be careful when you're building applications about how you're dealing with disposing of web and site objects. In terms of aggregation and roll-up, which, let's be honest, is the majority of custom code that gets done on a public-facing website. You've got your page content. You want to surface that in a sort of landing page or navigation page. Where possible, try and use out-of-the-box controls. So use list views, use content query web parts. Don't try and reinvent all of that. That's optimized code. It's going to run faster than the majority of the code that you will write. If you do want to do something a bit unusual, maybe you want to join information from lots of different sources, try and use either the portal sitemap provider, where you can insert an SP query object, or search. So search is a great way of getting around site collection boundary issues and things like that, but it's also much more performant than trying to go against the object model. And never ever iterate through list item collections and things like that, because that's just going to be slow. Every time you hit that new item in a list in a for each loop, that's going to bring all that data for that item back into memory. It'll be cached on the whole, but even so, it'll slow down your application. So a lot of the guidance that was there for 2007 is still completely the same here. Obviously, you should be deploying everything as features and deploying everything in solutions. That hasn't changed in 2010. And it's really important to think about the life cycle of the assets that you're moving across. So page layouts, master pages, CSS files, keep them uncustomized. You want to be doing that anyway from an ALM point of view. But from a performance point of view, if you customize pages, it's going to have to run through a safe mode parser every time that asset is requested, and that's going to slow down your performance. Finally, use caching. So obviously, this is a general topic. Use caching for any ASP.NET application. But in specific terms for SharePoint, make sure you're using output caching and make sure you've configured the anonymous cache profile properly. And look into how you use the blob caching so that it's not having to go back to databases to pick up your imagery and your PDF files and your Word documents that you're serving through your SharePoint farm. So the final piece in reducing the workload is about SSL. How do you make sure that resource-hungry application is not being done on your web front end? Right? It should be dealt with at the firewall or in F5 layer 7 switches or something like that. It shouldn't. The web front end is not the place which is optimized to do SSL termination, so you shouldn't be doing it there. Similarly, where you do have expensive workloads that you're writing, say you've got something which you know is going to take a lot of resource. Write a custom service app, get that off the web front end. Your web front end should be absolutely dedicated to servicing requests that are coming in. Okay. So just a very quick example here of. So this is what I would expect a public-facing website to have on it, with possibly the addition of the web analytics service. It doesn't have that big long list of 30-odd service apps, because you're not going to be needing performance point, I'm guessing, on a public-facing website. Certainly not if you want it to perform, or Visio, or any of these. Okay. So reducing the page payload. There's a number of key things that are going to affect your page payload. And when I say page payload, what I'm talking about is the total amount of data that makes up that the response from an initial request for a web page. View state can get very big. I've seen websites where view state is over a meg. You try and print it out, and it goes over 3 pages. You want to be making sure you're setting enable view state to be false wherever you possibly can, where you know if it's not going to change between page refreshes, between postbacks, make sure it's not being used. It's not got enable view state enabled. Make sure you've got valid XHTML without inline style. That affects the that will make your application the HTML that comes down the pipe cleaner, and also the browser will be able to render it faster because it's optimized to do that. And if possible, lazy load any JavaScript files you've got. So wait until the rest of the stuff's come down if you don't need it immediately, and then have a function at the end which says, after the page is loaded, go off and fetch all this JavaScript. That won't affect the overall page payload, but it will affect the amount of data that has to come down the wire before IE or Firefox or whatever starts actually rendering the content. And use compression where possible. So either compress them in your application, your CSS files and your JavaScript files. Either do that at build time when you're creating the files, strip out all the white page or the white space and minify them. Or you can use IIS compression to do the same thing on the fly, though obviously that's going to have an impact on server capacity, because that's another thing that's going to affect your, it's a process that's going to have happen on application start. In terms of a typical SharePoint site, about 50%, can't really read that, sorry, about 50% of the initial page payload is in JavaScript. The next highest thing is in CSS, I think. Yeah, in CSS, and then the rest of it's in imagery and HTML. So you need to be very careful about adding more JavaScript to that already quite big page payload. And you also need to start thinking about how to strip some of that stuff out if you're not using it. So if we just have a quick look at what that looks like. If I go to just an out-the-box WCM site in SharePoint, and I hit refresh, and I've got Fiddler working. Fiddler says, me hitting refresh on that page, because I didn't have any caching, resulted in 34 requests going off to the server. Now, IE has a threshold which says you can only have 4 requests go off to that to a single server at any given time. So what's happened is IE's had to wait until it's done a batch of 4, then it's waited for some of those to come back, and then it's done a batch of 4, up to 34 items. So reducing the overall weight of that is really important. If we have a look at the weight of that, we can see that that's looking like it's about 650K out of the box. So just like in 2007, never use the out-of-the-box layouts and page layout and master pages. You want to be stripping out as much as possible. You want to be using Randy Driscoll's starter master pages, which just have almost no content in them. You want to be trying to strip out as much of this stuff as possible. So let's actually just have a look at the page itself. So default.aspects is only 13K, so it's pretty, it isn't massive. If we go into SharePoint Designer and change enable view state to true, and then go and publish that, timed out. I hate SharePoint Designer. There we go. So if we check that in, okay, I'll just sign in, that'll work. Okay, so with it, like that, so we're at 23K there with it switched on. If we switch it off, that should drop back down to 16. So just by changing two settings on two controls, albeit quite big controls, navigation, we can see a dramatic increase in the page weight of a particular file. Now, in the grand scheme of things, 9K is nothing compared to the 650K that you're getting across. But that 9K, after the first page refresh, is going to be the majority of what you're going to see. So if I refresh the page and go back to Fiddler again, we've got all of these things here. If I clear this, so that's 39, because I'm logged in, I get a few more files. We can see that that's dropped down now to 25, and most of those are in 304s. So those will be all coming back at 0. So after the first page hit, once stuff is cached, that's going to, the page weight of the actual page itself is going to be much more relevant to the overall performance or the perceived performance of your site. Yeah, so that's now dropped from 600 and something to 33. Okay. So I could show you the caching model in 2010, but it's exactly the same as it was in 2007. There's a page in the site settings in the central admin where you can define what your object cache is and also what your cache profiles are when that loads. That's pretty similar to 2007. There's been a lot of work under the hood, but in terms of what you can set, that's pretty similar. Okay. So, reducing the number of requests. The best way of doing that is while you're building your application, try and have as few files as you possibly can. One CSS file, not 15. One JavaScript file, not 20. Despite the fact that you'll be downloading more content on that first hit, after that first hit, it'll probably be cached at the browser, so it won't come back. You won't be sending that down. So the first page payload will be slightly bigger, but after that it'll be smaller. And more importantly, you'll have fewer files to go and fetch. Right? So when IE is only issuing 4 requests at a time, that's going to be a significant factor. The second thing is to use Ajax and jQuery and RESTful APIs and Silverlight and so on to reduce the number of times that you have to do a complete page refresh. Every time you do that, that's going to add load to the server. You do need to be careful about that. That can get quite... You need to be aware of the impact you're going to have on server performance if you're doing a lot of JavaScript and a lot of Ajax. That's something when you're designing that you need to be careful of. And make sure you've removed as many of the out-of-the-box scripts in the CSS as you can. If you're not using it, it shouldn't be there. Now, SharePoint will put some of that stuff in. There's not a lot you can do about that, at least in a supported manner. So you need to do some work to remove those. And use CSS sprites. Does everyone know what a CSS sprite is? Hardly anyone. I'll quickly show you, because it's quite cool. Okay, so CSS sprites. One of the things we've got is when you're in a page, you've got a bunch of images. Now, if you were to try and download all of those images in one go, in the normal manner, that's going to result in a lot of requests going to the server and a lot of request processing happening, and then it comes back. What a CSS sprite can do is it's got a big image with all the little images that you need in that image in particular locations, and then you use CSS and JavaScript to go and get the right part of that bigger image and use only that little part to render out to the browser. So it's quite a clever piece of technology. And an example where it's used out of the box, let me just refresh that, is in the ribbon. So in the ribbon, you've got all the ribbon icons. And if you were building this in sort of traditional fashion, all of those images would be an image on the file system that would be downloaded one by one. That's not a very efficient way of doing it. So what they've got in here is if I have a look at this particular image, which is format map 32 by 32 PNG, and actually have a look at the raw content that's coming back here, if I can find the right view, there we go. So this is one image. It's a pretty big image, right? It's 260K. But it's one image that gets downloaded, and that's all your icons for the ribbon in one image. And similarly for the publishing stuff, you've got exactly the same. And you can use this technology. You know, there's open source implementations of being able to take this stuff in real time. So using CSS sprites is going to reduce the number of times the browser has to go and request stuff from the server. And once it's down once, it's generally going to be cached. So the other way of doing this, so the right thing to do is to do this while you're building your application. You should be thinking about doing this stuff as you're going along, not waiting till after you've deployed and then trying to do it. But if you do find yourself in a situation where you do have a slow website, there are third-party products available which may help. And one of those is a product called Aptimize. This is actually used on the SharePoint.Microsoft.com site. It does some stuff which is not officially supported from a sort of SharePoint support mechanism. But because it's easy to switch on and off, if you need to ring PSS, support, Microsoft support, and they ask you to switch it off, it's a pretty straightforward thing to do. So I'm just going to switch this on this website. And what this is doing under the hood is it's putting in a HTTP module and an HTTP handler, which analyzes the stuff as it goes out through the request pipeline, or the response pipeline, and intercepts things and creates CSS sprites and creates AXD files, compiled files, on the fly, and then caches that. So it's pretty clever. And what it can do, so I've just switched that on. If I go back to my home page, so because I've changed web.config by doing that, it's refreshed the app pool. So obviously this is a trial version, so I get a nasty logo at the top. But what it's done, I should have actually done this before, so we clear the cache. I'll show you a after and then before. So Fiddler tells us that this has 39 requests. Let's go back to stats. Actually, let me just clear the cache, remove that. So 39 was the optimal number we saw there. If I now switch it back off, and go to the same page, it's only 40. So when I did this upstairs, this went down by 10. Anyway, but the other thing it will do is it will minify all your stuff. So like I say, it's a useful tool for reducing the page payload and reducing the number of requests that actually end up going back to the server. But really, you should be thinking about doing this from day one in your dev projects, not relying on a third-party tool to do it. But there are always situations where you might want to use it. In an intranet scenario, it's useful for if you've got slow WAN connections and you're using out-of-the-box stuff and you don't have the luxury of being able to rewrite a bunch of that code. Okay. So then, I missed one thing on this slide. The other thing that you should be doing is splitting requests for images and CSS files and so on off to a different fully qualified domain name. So you'll see all the big sites do this. So BBC, for example, has images.bbc.co.uk. And the reason for that is, coming back to that limit of 4 requests from the browser instance at any given time. It's just 4 to a particular domain. When this first came in, people were worried about browsers being used as an attack vector for denial of service attacks, which is crazy. Why would you do that? But that's why Firefox, Opera, Safari, IE all have this limit. So if you've moved it to a different domain name, it can be even served on the same IIS website, just a different host header. What you'll find is your perceived performance from your end users will be higher. So I did that demo. So then the final thing to really talk about in terms of reducing, doing high availability and also high scale is the use of content delivery networks. So how many people are writing websites using CDNs at the moment in any given? No? Not one. Oh, one. So which one do you use? Akamai? Level 3, right. So basically what it is a caching mechanism around the globe which takes your content, and when an ISP gets a request for your content, unless it's transactional based content, it's something that they can, that the content delivery network will handle locally to that user. So if you've got a global reach, it's great because it means that that traffic doesn't have to go from Singapore to here or Australia or America to here to actually get that content. And that latency can be quite high, depending on the speed of the link that the end users have. Even at the backbone, it's going to take a few seconds to go from Australia to here and back, particularly if you've got a lot of backwards and forwards traffic. It also enables you to scale. So public-facing websites, if you're in a situation where you've got a very successful site, you're probably not going to be able to afford MOS Fizz license, SharePoint for Internet site licenses to service that. You're going to have to think about how to scale above that. But there are some limitations, so you shouldn't use it for personalized content. And you may need to change the way you're writing your applications to take full advantage. So that's like the traditional CDN, but there are other uses as well. So a lot of people will host video streaming on a dedicated CDN. They don't want their day-to-day web traffic to be affected by people streaming rich media. So you can host it. I mean, Microsoft and Akamai have a service, but there are lots of other services ranging from really small hosting companies through to the likes of Microsoft. The other type of CDNs are around hosting standard frameworks. So if you're using jQuery or Ajax or whatever, you don't have to serve those files from your servers. You can serve those from the Google API stuff or the Microsoft CDN stuff. And what that will do is have two effects. Firstly, that's traffic that's not hitting your server at all. So that's another set of page requests that aren't coming to your server. But secondly, the chances are that most people will have these cached in their browser. They won't need to go and get it at all. So that's going to have a perceived performance improvement for them. So high availability, not going to talk too much about this. This is really an IT pro scenario. But devs should be aware of the fact that we should be aware of farm topology when we're doing our development. There's also a number of improvements in 2010 that are quite specific to availability. So this isn't around performance because, whether it's in a sandbox solution or not, these are about catching things before they may have a performance impact. So it's about catching things before they hit the performance of your site. So the new health analyzer stuff, the new sandbox solution scenarios will make your overall platform more stable. You'll be less likely to be writing bad code, which is the leading cause of performance problems. And so while some of these have a slight performance hit through implementation, overall you should have a more stable, more highly available and higher scale site at the end of it. So that's pretty much it. The key takeaways that I think you should be taking from this session: you need to look at how to reduce the workload of your servers, whether that's looking at what the server has to do in terms of running your custom code, or how you're configuring your sites to be read-only or not, how you use caching to reduce the amount of work that the server has to do to service a request. You should be looking at reducing the size of the page payload so the least amount of data as possible gets sent down the wire to the end user in the least number of requests that end up coming back. But in order for any of this to make a difference, you need to be measuring, and you need to be benchmarking, and you need to be testing and retesting all the time during your process. If you leave this sort of stuff to the end, you'll never do it. Or at least, even if you do it, the results will not be meaningful because you don't know what it was like at the start. And if you invest in this kind of thing up front, you will be able to use that to go and get more budget, to go and build more interesting projects for your customers. So thank you very much. Are there any questions? Yeah.
Have you got any recommendations or best practices around testing, particularly automated testing for personalised sites? So basically where you need to actually log in as users because they've got personalisation requirements.
Yeah, so Whatin and the Visual Studio tools both have the capability to fill in forms, and the data that gets filled in as part of that process is able to be sourced from an XML file or a database or something like that. Sorry, the question was, are there any tools for doing tests, load tests and web tests against personalized content? So what you do is you'd set up a number of scenarios on a number of machines, and each scenario would go through the authentication process as the first step in its process, and then hit the pages you want to be thinking about. And when you're developing that kind of solution, personalizing the pages should be approached with caution, because if you've got personalized content, that means your page can't be cached in its entirety. It has to there has to be some processing on every request. And that will impact on the overall scalability of your solution. So you'll have to have more servers to deal with that. Okay. Martin.
In Vegas, I heard a rumour about the administrative toolkit for SharePoint 2010, allowing you to create automated Visual Studio scripts for load testing based on your ISOs. Any ideas where or when?
I heard the same rumours. So the rumours in Vegas at SharePoint conference around there being a toolkit delivered by the product team or the engineering team, which had the ability to automatically generate a bunch of load test scripts for doing this kind of thing. I've not heard anything since then, but I haven't asked that specific question to the product team. So I imagine there will be something like that coming out. There will certainly be guidance around this coming out, probably from the Patterns and Practices group, I would guess. Any other questions? No? Thanks a lot. So the dev panel's on in, I think, 15 minutes, is it, or half an hour? Or anyway, stick around for the dev panel. That'll be good.